Electrical wiring is a fundamental aspect of electrical systems, and understanding its principles is crucial for anyone working with electricity or managing electrical installations. A well-grounded knowledge of wiring practices ensures safety, efficiency, and compliance with electrical codes. This guide provides an overview of essential electrical wiring concepts, covering topics such as wire types, wiring methods, circuit design, and safety considerations. Firstly, wire types are categorized based on their material, insulation, and application. Copper and aluminum are the most common conductors, with copper generally preferred due to its high conductivity and corrosion resistance. However, aluminum is lighter and more cost-effective for larger gauge wires. Wire insulation is crucial for preventing short circuits and electrical shocks. Common insulation materials include thermoplastic high-heat nylon, cross-linked polyethylene, and rubber. The type of insulation is indicated by letters in the wire designation such as THHN, THWN, and XHHW. THHN stands for thermoplastic high-heat resistant nylon-coated wire, suitable for dry and damp locations with a maximum operating temperature of 90 degrees Celsius. THWN stands for thermoplastic heat and water-resistant nylon-coated wire, also suitable for dry and damp locations, but with added water resistance. XHHW stands for cross-linked polyethylene high-heat and water-resistant wire, offering superior heat and moisture resistance. Wire gauge refers to the size of the wire, with larger gauges indicating thicker wires that can carry more current. The American wire gauge, or AWG, system is used to standardize wire sizes. Common wire gauges in residential wiring include 14 AWG, 12 AWG, and 10 AWG for lighting and receptacle circuits, and larger gauges such as 8 AWG, 6 AWG, and 4 AWG for appliances and service entrance conductors. The appropriate wire gauge for a circuit depends on the ampacity, which is the maximum current the wire can safely carry. The National Electrical Code, or NEC, specifies the ampacity of different wire types and sizes in Table 310.15b16. Secondly, wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include non-metallic sheathed cable, also known as Romex, electrical metallic tubing, or rigid metal conduit, or RMC, and flexible metal conduit, or FMC. Non-metallic sheathed cable consists of two or more insulated conductors bundled together within a non-metallic jacket. It is commonly used in residential wiring for branch circuits and is relatively easy to install. Electrical metallic tubing is a thin-walled metal conduit used to protect conductors from physical damage. It is often used in commercial and industrial applications as well as in exposed locations in residential settings. Rigid metal conduit is a thicker-walled metal conduit that provides greater protection than EMT. It is used in areas where wires are subject to severe physical damage, such as underground or an industrial environment. Flexible metal conduit is a flexible metal tubing used to protect conductors in short runs or where flexibility is required. It is commonly used to connect equipment to junction boxes or to provide a flexible connection to motors and appliances. Proper installation of wiring methods is crucial for ensuring safety and compliance with electrical codes. This includes using appropriate fittings, supports, and connectors, as well as following guidelines for conduit bending and wire pulling. Thirdly, circuit design involves planning the layout and components of electrical circuits to meet the needs of a building or facility. A branch circuit is a circuit that extends from the final overcurrent protective device, such as a circuit breaker or fuse, to the outlets or equipment it supplies. Branch circuits are typically classified based on their ampacity, such as 15 amp, 20 amp, or 30 amp circuits. A 15 amp circuit is commonly used for lighting and general purpose receptacles, while a 20 amp circuit is used for kitchen and bathroom receptacles, as well as for small appliances. A 30 amp circuit is used for larger appliances such as dryers and water heaters. Circuit design also involves determining the appropriate number of outlets and lighting fixtures for a given area, as well as calculating the total load on each circuit. The NEC provides guidelines for determining the minimum number of outlets required in different rooms and spaces, as well as for calculating the load on each circuit. Load calculations are based on the volt-ampere rating of the equipment and appliances connected to the circuit. It is important to balance the load on each circuit to prevent overloading and ensure efficient operation of the electrical system. Fourthly, electrical safety is paramount when working with electrical wiring. Electricity can be dangerous if not handled properly, and electrical shocks and fires can result from improper wiring practices. Grounding is an essential safety measure that provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All metal enclosures and equipment must be properly grounded to ensure that they are at the same potential as the earth. Ground fault circuit interrupters, or GFCIs, are devices that detect small imbalances in current and quickly shut off power to the circuit, preventing electrical shock. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or RFCIs, are devices that detect arc faults, which are dangerous electrical conditions that can cause fires. RFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Safe work practices are also essential when working with electrical wiring. This includes turning off power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment such as safety glasses and gloves. Fifthly, the National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations. The NEC is updated every 3 years and provides detailed requirements for wiring methods, circuit design, grounding, and other aspects of electrical systems. Compliance with the NEC is essential for ensuring the safety and reliability of electrical installations. Electrical inspections are conducted by qualified inspectors to verify that electrical work complies with the NEC and other applicable codes and standards. Inspections are typically required for new construction, renovations, and alterations to existing electrical systems. Passing an electrical inspection is necessary to obtain a certificate of occupancy and ensure that the electrical system is safe and code compliant. Sixthly, troubleshooting electrical wiring involves identifying and correcting problems in electrical circuits. Common electrical problems include open circuits, short circuits, ground faults, and voltage drops. An open circuit occurs when there is a break in the circuit, preventing current from flowing. A short circuit occurs when there is an unintended connection between two conductors, causing excessive current flow. A ground fault occurs when there is a connection between a conductor and ground, causing current to flow through the grounding path. A voltage drop occurs when there is a decrease in voltage along a circuit, typically due to excessive resistance or overloading. Electrical testing equipment, such as multimeters, circuit testers, and wire tracers, are used to diagnose electrical problems. A multimeter is a versatile tool that can measure voltage, current, and resistance. A circuit tester is a simple tool that can indicate whether a circuit is energized or not. A wire tracer is a device that can be used to locate wires behind walls or in conduit. When troubleshooting electrical wiring, it is important to follow safe work practices and use appropriate personal protective equipment. This includes turning off power to the circuit before working on it, using insulated tools, and wearing safety glasses and gloves. Seventhly, electrical wiring for lighting involves selecting and installing lighting fixtures and controls. Lighting fixtures are available in a variety of styles and types, including incandescent fluorescent light-emitting diode or LED, and high-intensity discharge or HID. Incandescent lamps are traditional light bulbs that produce light by heating a filament. Fluorescent lamps are more energy efficient than incandescent lamps and produce light by exciting mercury vapor. Light-emitting diode lamps are highly energy efficient and long-lasting, producing light by the movement of electrons in a semiconductor. High-intensity discharge lamps are used for high-output lighting applications such as streetlights and parking lot light. Lighting controls include switches, dimmers, and occupancy sensors. Switches are used to turn lights on and off, while dimmers are used to adjust the brightness of lights. Occupancy sensors are used to automatically turn lights on when someone enters a room and off when the room is unoccupied. Proper lighting design is important for creating a comfortable and functional environment. This includes selecting appropriate light levels, color temperatures, and fixture locations. Eighthly, electrical wiring for receptacles involves selecting and installing receptacles and related devices. Receptacles, also known as outlets, are used to provide power to appliances and equipment. Receptacles are available in a variety of types, including standard receptacles, ground fault circuit interrupter receptacles, and arc fault circuit interrupter receptacles. Standard receptacles are used for general-purpose applications, while GFCIs are used in areas where water is present and of size that are used to protect against arc faults. Receptacle wiring involves connecting the hot, neutral, and ground wires to the appropriate terminals on the receptacle. It is important to ensure that the wires are properly connected and that the receptacle is securely mounted in the outlet box. Tamper-resistant receptacles are required in many areas of the home to prevent children from inserting objects into the receptacle slots. Ninthly, electrical wiring for appliances involves selecting and installing wiring and related devices for appliances such as refrigerators, stoves, and washing machines. Appliances typically require dedicated circuits to ensure that they receive sufficient power and to prevent overloading the electrical system. The size of the circuit and the wire gauge required for an appliance depends on its volt-ampere rating. The NEC provides guidelines for determining the appropriate circuit size and wire gauge for different types of appliances. Appliance wiring also involves connecting the appliance to the circuit using appropriate cords, plugs, and connectors. It is important to ensure that the appliance is properly grounded to prevent electrical shock. Tenthly, electrical wiring for special applications involves selecting and installing wiring and related devices for specialized electrical systems, such as fire alarm systems, security systems, and low-voltage lighting systems. Fire alarm systems are designed to detect fires and alert occupants of a building. Security systems are designed to protect buildings and property from unauthorized entry. Low-voltage lighting systems are used for landscape lighting, accent lighting, and other decorative lighting applications. These specialized electrical systems require specialized wiring methods and components. It is important to follow the manufacturer's instructions and applicable codes and standards when installing these systems. Understanding these essential electrical wiring concepts is crucial for anyone working with electricity or managing electrical installations. A thorough knowledge of wire types, wiring methods, circuit design, and safety considerations ensures the safety, efficiency, and compliance of electrical systems. Continued education and training are essential for staying up to date with the latest codes, standards, and technologies in the electrical industry.